All right, we're looking at three different sets of parametric equations. We're asking how do the positions of a particle that's following or three different particles following these three different rules, what's the relationship between their positions at any given time? Well, we could go ahead and graph them and make tables and check it all out, but for these first two, let's take a look here. Notice that this is plus 6t and minus 2t, and here we've got plus 6t minus 2t. So for rules A and B, the x and y coordinates are changing at the same rate, but this point starts at 7, negative 2, and this one starts at the point 3,5. So these two are following parallel paths. So they're never going to be at the same location, ever, because they're starting out at different places. This one here, I guess if we were to graph it, let's see if I can fit this graph in here. All right, 3, 5, 1, 2, 3, 1, 2, 3, 4, 5. And then here, this one is 7, negative 2, 1, 2, 3, 4, 5, 6, 7, negative 2. Okay. And then this one goes 1, 2, 3, 4, 5, 6, and down 2. And this one goes 1, 2, 3, 4, 5, 6, and down 2. Okay. So this is A, and this is B. So A and B follow parallel paths, but they are never going to be at the same set of points. This one's always going to be at any given point in time. This point up here will be, up and back a little bit from where this one is. You could calculate, I suppose, exactly what the difference between them is going to be, because it's going to be the same as their starting points. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So it's always going to be 4, negative 7 to travel from particle A to particle B. All right? And they're going to stay in that, with that relationship all the way. Now C is a little bit different. Because notice that C has the same starting point as A, but something's been done, and we got the same rate of change, 6 and 2, 6 and negative 2, negative 2, but we've added 1 to the t before we multiply it by 6. So we just replace t with t plus 1. We'll see what that does. And let's take a look at a table real quick. Let's see, so for this first one, when t is 0, x is, 3 and y is 5, and then we're going to say, so that gives us 9 and 3, and let's see, gives us 15 and 1, and we just keep adding what 6's, right? So it's 21, 27, 34, and 40, and we keep subtracting 2, so it's negative 1, negative 3, negative 5, negative 7. So here's where the first rule is at any given time. And over here, it's kind of like, by adding 1 first, if I make t 0, then it's t plus 1 becomes 1. So when t is 0, we get the same as if over here t was 1. So right here is the output we get when t is 0. When t is 1, well, 1 plus 1 is 2. So this is the same as we got over here when we plugged in 2, 1. When t is 2, well, 2 plus 1 is 3, and so we should get the same output as we did over here when t was 3. So 2, 3, 4, 5. So you can kind of see that what happens is all of the outputs just get shifted, right? In fact, we reach every given point that we reach all the same points using this rule that we did using this set of rules. We just get to them a little earlier, right? So we get to this point at t equals 0 instead of t equals 1. We reach this point at t equals 1 instead of at t equals 2. and so on. So this particle here travels the exact same path as this particle, except it just reaches all of the points a little bit earlier. In fact, there are some points, I suppose, down here. Well, I mean, we get those with negative time, but whatever. And this sort of shifting, by the way, shows up a lot in Algebra 2. You'll see that a lot where they shift functions around by changing the rules, by replacing a t or an x or y or whatever value with a +1 or a -1. So notice how the +1 shifts us our input values forward, but we can think of that better as shifting our output values backwards. Right? So, and then if we were to subtract, it would shift the other way, and all of our output values would get kind of shifted forwards in a sense. Maybe play around with it and kind of figure out what that looks like.